Okay, so on the beauty of physical argument, we are on part 5, circular reasoning. And I wanted to do a quick video on this because if you are a philosopher or a logician and you observe what I've shown you so far, and if you are keen with mathematics, you may have noticed something. So we're going to do a bit of an equation flowchart here. Okay, so starting with the principle, let's call it the principle of least action. If you assume that that is a ground level axiom, what we started with was you needed to know, well, I needed to know that EK is half mv squared. You needed that. We didn't need any particular form of the potential energy other than the fact that it was a function of position. Okay, this is our first line. Then we applied the principle of least action to it. Okay, we applied the principle of least action, T1 to T2, to this system, which is EK, I always get that backwards for some reason, EK minus EP dt, where S is minimized. And we discussed that in the previous video, so I'm not going to go over it too much here. Okay, now seemingly, this told us that the mass, it told us that the mass times the acceleration was equal to the negative differential of energy with respect to position. Okay, so seemingly it gave us this, and then, well, let's do the next arrow. If you have this as true, then because of one of our other postulates, because I told you way back that an observed phenomenon is that P dot is equal to the negative partial differential of energy with respect to x, then you can reason that P dot equals ma. And we give this P dot a special name, we call it force. Now, you may be wondering now, we're almost coming back to something else we've seen. Okay, let's go up. Let's really do this graphically. P dot equals ma. I also demonstrated we can do it quickly here. So it's d by dt on P, and you can do a derivative here as well, d by dt on V. So this greatly implies, let's shift this down and give ourselves some space. This greatly implies that P is equal to mv. Okay, well, remember the other side of this coin. So there's another side of this equation that I've talked about. It's an anti-symmetry sort of principle. And then if you take x dot equaling partial dE by dP, now we're in strange territory because this is V is, this equation gives rise to EK equals half mv squared. And I showed that in a video as well. So it is very much tempting to say that this, in fact, is circular reasoning and feeds what we derived in the first place. However, I will caution that the purpose of this theory is not to have a sort of linear explanation for nature and how nature functions. So there's let's do it in a different color. There's a temptation to say that we are implying circular reasoning and therefore it is false. I'm going to say a couple things. First of all, the fact that the speed is a partial differentiation of energy with respect to momentum. So I'm going to overlap that a little bit. Let's draw this out a little bit. Okay, the fact that I said speed is a partial derivative of energy with respect to momentum is just as much of a definition as saying P equals mv. Okay, these two are not so separate. There is no, until you, let me try to describe this in another way. Until you define what momentum is, how are you supposed to take the partial derivative of energy with respect to momentum and get anything sensible? So by virtue of defining momentum to be mv, then we can say that x dot, the speed, is the partial differential of energy with respect to momentum. So I'm going to remove this arrow. That's the first line of erroneous thinking. The other point of this was to demonstrate that we do not need to, let's say, do you need to assume that P equals mv? And the answer is no, you don't need to assume it. The principle of least action, the theory of the principle of least action gives us, so the PLA gives us P equals mv. The observed phenomenon is that EK equals half mv squared. The energy of a moving particle goes with the square of its speed. This is an observed phenomenon. There is not circular reasoning here. So I did want to do a quick video explaining this because it's very tempting to convince yourself that this whole setup involves circular reasoning and is therefore false. But it's not true. It's not true for two reasons. One, because this quantity doesn't gain meaning until we define momentum. And the principle of least action relies on the fact that kinetic energy is observed to go with the square of the speed. This is an observed phenomenon. Otherwise, we have no definition for it. Okay, so yeah, I just wanted to do a quick video on that. In the next video series, we're going to get back into the inverse square law, and then we're going to get into elliptical orbits. It should also be stated that the inverse square law, and just sort of an addendum to what I just said, but the inverse square law, we said that the acceleration is equal to some negative times a constant times mass over r squared. And I sort of told you that the acceleration was equal to this inverse square law. But now I'm telling you that in addition to this, that F equals ma. F equals ma. The force on an object is proportional to the acceleration. This motivates this to have physical meaning. It motivates it to have physical meaning. It's not sort of drawn out of thin air. If you want to think of it as a supporting argument, this is like a supporting argument for the inverse square law. And of course, I'm jesting here philosophically. All of these equations can be confirmed experimentally with data. When we know what we mean by position, when we know what we mean by momentum, and we can measure things like potential energy, we can measure things like kinetic energy. And basically, the data confirms. And in fact, it should be worth noting that the experimentalists observed these laws long before the philosophical arguments were here. So it's an important point on the scientific method and the way that physics operates, is that the experimentalists will almost always certainly discover the laws before we understand them from a point of philosophy. Okay, guys, like and subscribe if you like this kind of stuff, and I'll catch you next time.